In Part 7 of Lecture 1, we discuss redirection, pipes, and processes. As I said earlier, redirection is about replacing standard input or standard output with a file. Now we know ls will list files that are in the directory, and these file names will appear on the screen. If I write instead ls and a greater than sign, file list, it will create a file, and the file will contain the names of the directory files. Similarly, I could write cat f1, f2, f3. Normally, that would have the contents of the file appear on the screen. However, if I write cat file1, file2, file3 greater than temp, the contents of those files will appear in a file called temp. If the file already existed, it's going to be overwritten. Now, if I wanted to do this and have it not overwrite the files, rather than write greater than temp at the end, I would use two greater than signs. So it would read cat f1, f2, f3 greater than temp. In that case, what will happen is that if the file already exists, the contents of these three files will appear at the end of what previously had been there. Now, normally, using the Unix mail utility, we would type mail space Mary and then the enter key. And then after that, we would have to type our mail message, whatever it is, and we would end it by hitting Control D. And by that I mean holding down the Control key and pressing D. If instead I wrote mail Mary and then afterwards less than message, the mail would include the contents of that file. We can, just as we can redirect input by using a greater than sign and then the name of the file, I can redirect input by using a less than sign and then the name of the file. Think of the greater than or less than sign pointing to whether input is coming in or output is going out. I should also note that on Panther and CompSci, the mail utility doesn't work, so we're not going to use it here. What you see on the screen right now are 5 different examples of what we get from redirection. Who greater than temp will place in the file temp the names of users currently on the system, as well as the terminals on which they've logged on. Sort less than temp will then print them in alphabetical order based on username. Who greater than temp, again, will save the names of the users and their terminals in the file temp. WC space -L less than temp will give us a count of the number of lines. The -L option with WC is to give us just the number of lines. ls greater than temp will save the names of the files in the temporary file. PR space -3 space less than temp will print them, will display them on the screen in 3-column printing format. Who greater than temp will list everyone who is logged in the file temp. grep Mary less than temp will print Mary's login line from who, if she is in fact logged in. Sort less than temp will do the same thing as sort temp, because it is common to use this with a file, and the temp command allows that. We can use filters like sort even without a file. In this case, what I did was I typed sort, and I type in the lines DEF, on the next line IJK, on the next line ABC, and a Control D ends the file. it then will print back to me the 3 files in sorted order. As useful a tool as redirection is, we don't need to use temporary files if I want to take the list of people who are logged in and then sort them or count the number of lines or whatever. I can take advantage of another little tool called piping. As you see here, I can write who, a vertical line, and then sort, or who, a vertical line, and then WC space -L, or LS, vertical line, WC space -L, or LS, vertical line, PR space -3, or who, vertical line, grep Mary. What this does is it takes whatever standard output I have from the first program, and then it becomes standard input for the second program. Any program reading the keyboard and displaying on the screen can use a pipe, just as I did here. What you'll notice here is I read who, grep Mary, so I will print any line showing where Mary is logged in, and then WC or word count with the -L option, meaning all I'll get is lines. This will give me the number of times that Mary is logged in. Every program that runs on a Linux or Unix system will always have 3 files available to it. stdin is standard input. Normally this is the keyboard. stdout is standard output, and this is usually our screen. There's also stderr, standard error. Standard error will also go to the screen. Now, given that standard output and standard error are both going to the screen, one might wonder whether I really need both of them. But I can redirect either one of these to a file if I wanted to, or I could redirect them both to 2 different files. And for that reason, it becomes very helpful. In terms of redirecting standard output, that's something that we'll talk about later in the term. A process is the act of running a program. If I'm on the system checking email, and a student is on the system checking his or her email, and a third student is editing a file, that's 3 separate processes right there. The proper use of a shell means that we can run 2 processes with 1 command. As you see here, I'm typing date, a semicolon, and who. The semicolon is a separator here between the 2 commands that I've given, and they will be performed in sequence just as you see it here. Most of the programs that we run on a Linux system are interactive. We type in our input and we get our output back on the screen. Now we can also run programs in the background, and this is essentially the same as a batch in that we won't necessarily see what's going on while this is running. We can work on something else. In the example that you see here, WC CH asterisk, we're going to find a word count, get the number of lines, words, and characters for each file in this directory beginning with CH. The output will be sent to a file wc.out. The ampersand at the end tells us that it will run in the background. What we see on the next line, the number 12,909, is the process ID number. We can then print out the file and we will see the output in question. In the example that we see here, PR space CH asterisk will display all of the files beginning with CH in printable format. the output we get from this is sent to the line printer, which in this case is a printer that is attached to this computer. The asterisk, the ampersand at the end applies to the entire pipe, and the entire pipe is run in the background. We see the process ID number here as 6951. The wait command will make the computer wait until all the processes are finished. Then afterwards, what I can write is kill space -9 space 6944. That will kill the printing process, and as a result, it would not print out after all. PS stands for process status. In this particular case, what we are writing is PS space -AG, which gives all the listings for the programs that we happen to be writing. And here you can see them all listed: process identification numbers, terminals associated, and so on.